Hello everyone. Today we gonna learn how to create this fun inflatable tube man inside Houdini using Vellum. I don't care if you are not ready. We are starting. First, we gonna model the basic shape using 3 tubes. I delete some polygons on the body cylinder, then connect it with the hands using poly bevel. One thing I would mention is that we need to create groups for the bottom points and the ones that are connecting hands to the body. Let's call the latter seams. Now let's set up Vellum constraints. We'll start with Vellum cloth and then add Vellum struts constraints to simulate the volume inside. These are the constraints we'll be animating and then adjusting during simulation, so make sure to turn on the output group checkbox and name it something like volume. We also need to pin the bottom points of the body using Vellum constraints in pin to target mode. Now let's work on the constraints. First, let's transfer all the groups from the geometry output on constraints and promote them onto primitives. This will allow us to harden the constraints on the seams, to make them bend a bit less than the rest of the cloth. I'll just use primitive wrangle for this and multiply stiffness for the seams group by some number, like 10 or 100, but you can also do this using the attribute edit node. We also need to copy the rest attribute to points, which I created a bit earlier in the modeling stage. Rest attribute is created from a slightly modified geometry, where the hands are aligned vertically instead of horizontally, and you'll see later why. Next, we'll create a point VOP node, and we'll use a simple turbulent noise that uses rest position instead of the P attribute, and we squeeze it a lot on the Y direction and animate Y offset. Let's send the results from noise to color, so that we can see how it works. You can see that since we have the noise over the rest positions when we animate it through offset, it goes up on the body and from the center to the sides in the hands, which is exactly how the air goes inside a tube man. So now we need to promote the color attribute from points onto the primitives, which allows us to control the stiffness attribute on the constraints by multiplying them with color. Don't forget to adjust only the volume group of the constraints. Let's also create a piece attribute on the constraints to match them later during the simulation. I am using primitive wrangle, but you can just put an enumerate node instead. Okay, now all that is left to do is to send everything into the DOP network with Vellum solver. But the only thing that we need to be mindful about is that Vellum only reads geometry and constraints at the first frame of the simulation. So to get all the updated constraints, we would need to drop a SOP solver inside the DOP network, dive inside, and put object merge to grab our constraints from the SOP level and put an attribute copy node with CD and stiffness attributes and in the primitive mode of course. Don't forget that on the SOP solver you would need to put constraint geometry into the data name because we want to run over constraints and not the simulation geo. Okay, that's it. Run the simulation and watch the tube man becomes alive. Try increasing the substeps on the solver to get better results. I've used 3 substeps with 150 constraint iterations. Now you can cache the simulation, and copy all the attributes that you forgot to apply before the simulation, like I always do with UVs. Place a Vellum post-process node to smooth out the mesh and you are ready for render. You can use this technique to do all kinds of different effects. I used it to create this worm animation for example. Thank you for watching. Please hit like, add this to your tips and tricks saved folder, and share with everyone including those friends who don't care about computer graphics at all. Also, let me know if you are interested in this type of content, and maybe I'll manage to find a better text-to-voice tool that I can use.